Let's talk about the regression function on your calculator. The regression function is really nice for determining the best fit of a line. For example, let's say I give you some points like x and y. I'm just going to give you some points. Let's say like 5, 7, 8, 9, 1, 5. And the y values corresponding to those are 1, 5, 4, 5, 1, 4. And I want to know the line of best fit. Well, what I can do is I can go to my stat, edit, and type these in. So this is going to be L1 is X and L2 is Y. So I'll just type those in 5, 7, 8, 9, 1, 5. Enter between. And then I'm going to go over to L2 is Y. So that's going to be 1, 5, 4, 5, 1, 4. Make sure that they line up. Often when you're typing them in, I'll make a mistake and I'll do something like this and the two lines aren't the same. The number of items in L1 is different than the number of items in L2, and that's a problem. So just make sure that you double check that this is correct. Once you have it correct, you can quit and then go to Stat, Calculate, and then let's do a linear regression. So that linear regression here, I'm going to hit Enter. Now, this is where some calculators are a little bit different. In all cases, just hit enter until you have your answer and it should work out. So I'm just going to hit enter a few times. In this calculator, it just scrolls down. I actually find this annoying. I like the 83 better because you only have to enter once. But in either case, you just hit enter a bunch and it gives you your answer. So in this case, we have a function. We have y equals 0.52x plus 0.28. And that's the linear regression. Basically what's going on, I don't want to plot all these points exactly, but basically you have a bunch of points, whatever they are, and we just found the line that best goes through them. Now, this is missing a very important detail, and that's the correlation coefficient. Some calculators will by default show them and some will not. So if it doesn't show it, like mine, I have mine purposefully set to not show it so that I can demonstrate the problem. If yours is like mine, that it doesn't show it, what you'll want to do is go to the second catalog. It's under the 0 key. And scroll down until you see Diagnostics On. So it's in alphabetical order, so I'll just keep going to DI. There we go. There's Off. There's On. We want to turn on Diagnostics. The reason why is it gives you a much, much better situation. So I'm going to go back and do my linear regression here. And it gives me the same answer. But now you'll notice it has R. Specifically, r squared is what really matters. R squared is 0.64. What that means is if this number is close to 1, that means we have a tight regression. So for example, like if we had these black regressions I have here, that's probably about right. It's not very good. But if I had some dots like this, that's a lot better, right? This line really fits with those red dots. That would be more like an r squared equals 0.99 or something like that. So that R value tells you how close your data fits to the line you chose, which really, really matters. I highly recommend you turn on that diagnostics and have that there. So having said that, let's go on to another example. Let's say we only have 2 points. Like for example, in algebra, you might just be given, okay, here's a point 1 comma 3 and another point 2 comma 5. And you want to find the equation of the line that goes through them. Great. You could do this using point slope form, slope intercept, whatever you want to do there. Or we can actually just use this as a regression on our calculator. I'm going to put the x's here, 1 and 2, and the y's here, and treat it exactly the same as I did before. So I'll go to the stat, edit, and then notice that I have a bunch of values I need to clear out. You could just hit the delete key one at a time and delete them, but that takes time. So I recommend you actually, if you have stuff in there like I do, hit up so that you're highlighting L1. And then anything you do will apply to the entire list. So if I hit clear, don't hit delete by the way, and enter, then it clears it out. Now I just go over to L2, hit clear and enter, and I'm ready to go. So I'll go back here to 1, 2, and then 3, 5. And from there it's the same. I'll quit, go to stat, calc. We want a linear regression number 4. Just enter a bunch. Don't worry about the rest of this stuff. And there we go. You'll notice we have y equals a, where a is 2, x, plus b, where b is 1. Also notice that r squared is equal to 1. If r squared is equal to 1, that means this is a perfect fit. These points fit exactly to this equation, which is great. All right, let's take a look at another example of where I think this is very useful. Here we have a table that shows us a bunch of different values for x and y, and we were not told what we have. Is this quadratic? Is it linear? Is it cubic, quartic, quintic? We don't know. But we're asked to figure it out. Now, in the algebra classes that I've taught, you often are taught that you should find the difference between so that you can determine what type it is. And I find that that is just horrifically difficult. Instead, let's just ask the calculator to tell us. So what I'm going to do is basically the same thing you would expect. I'm going to go stat edit. Now, since these lists are shorter, I don't need to clear it out. I'm just going to do -1, 0, 1, 2, 3. And then up here, I'll do 0, -1, -10, -9, and 20. Hopefully I typed all that right. And then we'll go back, go to the stat calc. Now in this case, I've only shown linear regression so far. But we can also do a quadratic, that's an x squared, or a cubic, that's a cubed, or a quartic, that's going to be a fourth power. And so what I'm going to recommend is just choose the highest power. When you're given a problem like this, just choose a quartic. If they don't tell you what type, just choose the highest power possible. If they tell you what type, you better choose what they said, because what I'm saying here only works if these numbers are perfect, if r is equal to 1. So I'm going to go to quartic. And then just go down, enter a bunch, whatever you need to do there. And here we go. So we get y equals a, which is 0. So I'm not even going to bother writing it. And plus b, which is 3x cubed, plus, so minus 4x squared minus 8x minus 1. So that's our answer. If we scroll down here, you'll also notice that r squared is equal to 1, meaning it fits it exactly. So now, well, what was this? Obviously, it was a cubic because the a value was 0. So it's not a quartic. So basically, you can tell from what the calculator gives you what it is. We didn't have to compute those differences. So these are several ways that you can use the regression function on your calculator to do whatever calculations you want to find. Generally, it's for finding lines of best fit, finding out what works well. I found that I've used this in my own real life to use this regression to predict what's going to happen in the future, given some current stuff. But I'll let you figure out how you want to use this in real life on your own.